Hello guys. So my name is Shafin and today we are going to discuss about a topic named recursion. So the main objectives of this session is to know what is recursion, what are the general steps that are to be followed while solving a recursive problem, complexity analysis of a recursive function, and then we'll do this problem, English ruler problem, that will help us in understanding how to identify and observe patterns that will help us in defining a recursive function, right? So let us start with a bookish definition of a recursion. A function that calls directly or indirectly is termed to be as a recursive function. A function that calls itself directly or indirectly is known as a recursive function. To understand this more clearly, let us take a real life example. Suppose there is a person A, fine, and the task given to person A is to count number of items present in this box. Let's suppose this box consists of 1000 items and the task of person A is to count these many items. This is a highly inefficient task. It will take him many hours to do so. Fine. But person A is a smart person. What he did, he contacted person B, divided the box items in any way. Suppose he said that take X items from box, and person A decided to count remaining 1000 minus X items. Fine. So in case 1, let us suppose that this was the case 1. In case 1, person A had to count all those 1000 items by himself or herself. In case 2, person A contacted person B, divided the box items in two parts, one containing X items and another containing 1000 minus X items. Person A assumed that person B will give him correct count present in the box divided by person A. Fine. Now, if we observe realistically, a person who has to count all these 1000 items will take a lot, many hours to do so, right? However, if there are two persons doing the same task, there will be definitely some reduction in time to complete the task, right? Now, person B. Person B is also a smart person. Person B thought that if person A is also dividing the task, why can't I? So he also contacted person C and person D. Fine. Divided these X items into suppose Y items and gave X minus Y items to person D. Now, at first, person A had to do all the task, right? Person A had to do all the task. 1000, he had to count all these 1000 items. In case 2, person B has to count X items, give the correct count to person A. Person A is assuming that person B will give him the correct count. And person A's job is to count remaining 1000 minus X items. Case 3. In case 3, person B observed person A and did the same thing. He divided these X items into Y items and X minus Y items, contacted two person C and person D. Both these person have same task to count those items and give the correct count back to person B. What will happen at last? Look, if suppose every person does the same thing, keeps on dividing items and contacting person, there will be a level or there will be a situation when the items cannot be divided further or there will be no meaning in dividing those items. Suppose uh, at last 9 items are left. Now you tell me, is it really efficient to call two more person to count 9 items? I can count this within a minute or within a second. So why do we contact more two person, right? So this is the base level. Okay, this is the base level. Suppose a person F uh, got a box with 9 items and he thought that, look, this is very easy to count it, so I'm not calling any more person, right? Now, recursion works in this manner only. Fine. Recursion works in this manner only. The original problem was given to person A. Okay, if I write here, original problem was to count total items present in a box. present in a box. Fine. What person A did? He divided items, right? And reduced his self-work. At first, his self-work was to count 1000 items. Now his self-work is to count 1000 minus X items. He reduced his self-work. Fine. He reduced his self-work and assumed, this is very important, okay? I will write 4 general steps that will help you in solving recursive problems. And assumed that person B will give him correct count. Correct count. And person B's job is to count X items. Fine. Person B did the same thing. Person B divided these X items into Y items and X minus Y items. Assumed that person C and person D will give him correct count, and he will give the addition of those count back to person A. Now, person B is much smarter than person A. Why? Because person B's self-work is minimal. He is not counting anything. He is simply adding the counts received by person C and person D. Fine. But he is also assuming that person C and person D will give him correct count. Fine. What is the self-work of person B? I can write as count received by person C plus count received from, sorry, not by, received from person D. Fine. So suppose person C gave him A number of items and person D gave him B number of items. Person B's job is to give A plus B number of item back to person A. Fine. So this is a clear example of recursion. Why? Because every person is trying to minimize his self-work. Every person, let's say, is trying to minimize his self-work. His self-work by assuming that other are returning correct output or correct result or correct count. Fine. There's one more catch in this, okay? Base level. There will be a time when there will be no meaning in dividing number of items. Fine. So I can write here that there will be a time when there is no meaning in dividing items or reducing self-work. Fine. So using these two points, now I'm going to define recursion in a technical way, right? So let's do first, let's map the problem to technical terms. Here, original task was to count 1000 items, right? So this was my bigger problem, okay? This was my bigger problem or original problem. Bigger problem was to count 1000 items, right? My smaller problem was to count. Okay, there are many smaller problems if you observe carefully in this. My first smaller problem was to count 1000 minus X item, and this was counted by person A, right? To count what? X items by person B. To count what? Y items by person C. And to count 9 items by person F. This is also a smaller problem, which will be returned, and the result of the smaller problem will be returned to the parent problem. What is the parent problem? Parent problem is person A. Child problem is person B with respect to person A. Person C is a child problem with respect to person B, and so on. Fine. So these all are valid smaller problem. Why? Because here you have to do less work as compared to bigger problem. Fine. In bigger problem, you have to count whole 1000 items. In smaller problem, you have to count minimum number of items, right? So all of these are smaller problem. What is the smallest problem if I ask you? Smallest problem. Smallest problem is to count 9 items, and this is done by person F. Fine. This is done by person F. Fine. Now, using these terms, bigger problem, smaller problem, smallest problem, I am deriving 4 steps that you should follow while solving a recursive problem. And after writing down those steps, I will take one program or one coding problem, that is to find factorial of a number. And after that, I'll take a English ruler problem that will help us in understanding recursion more properly. That will help us in identifying how to divide a bigger problem into smaller problem. Right? So steps. First step is identify the bigger problem. Identify the bigger problem. Person A identified that the bigger problem was to count 1000 items. Fine. Identify the bigger problem. Identify the smaller problems. Assume that smaller problems return correct result. Identify the smallest problem. Smallest problem. Fourth, do the self work. Do the self work and return the output, or return the result, or return the count. Fine. These 4 steps will help you in solving any recursion problem. Fine. So let us take an example of factorial, finding factorial of a number. Finding factorial of a number. And I'm asking you to find factorial of a number, let's say 10. Fine. Find 10 factorial. Identify the bigger problem. I want you to solve this using recursion. So identify the bigger problem. Let's say bigger problem means BP. So identify the bigger problem. Bigger problem is to find factorial of a number. Factorial of a number n. Or in this case, let's say find factorial of a number 10. Fine. What will be the smaller problem? Smaller problem can be many. There can be many smaller problems. So one smaller problem can be factorial of 9, factorial of 8, factorial of 7, and so on. Factorial of 1. Fine. Or factorial of 0 as well. Factorial of 0. Now, seeing these smaller problems, seeing the set of these smaller problems, what is the smallest problem? I can say that the smallest problem is factorial of 1 or factorial of 0. Both of them yields 1. 0 factorial equal to 1, 1 factorial is equal to 1. Factorial of 0 and what factorial of 1, right? So now what can be my self-work? If I divide my bigger problem into these smaller problem, what will be my self-work? I want to know this. If I'm dividing 10 factorial and I'm saying that smaller problem can be 9 factorial, smaller problem can be 7 factorial, 8 factorial, 3 factorial, so on. What will be my self-work? If I have divided this bigger problem into 9 factorial, suppose if my smaller problem I chose is 9 factorial, then my self-work in order to find 10 factorial will be 10 into 9 factorial, right? This is equal to 10 factorial. This is my self-work. I will rely on this smaller problem that this will give me correct result, which is correct value of 9 factorial. I will multiply it with 10. This is my self-work and I will get 10 factorial. Fine. But so if I choose smaller problem as 8 factorial, my self-work will become, let's say this is SP. So SP into 9 into 10. I have to multiply with 2 numbers this time. Fine. Observe it carefully. In this, I was multiplying with 1 term. In this, I am multiplying with 2 terms. If I take smaller problem as 7 factorial, my self work will be 10 into 9 into 8 into SP. This time I'm multiplying 3 terms. Our objective should be minimize our self work. In which case do you think the self work will be minimal? I believe that in this case, I believe that my self work will be minimal. Fine. So I'm writing it clearly. It's becoming a little messy. So let me write it clearly. Bigger problem was to find, now I'm generalizing it. Fine. Let's suppose I need to find factorial of n. So bigger problem is to find factorial of a number n factorial. Let me check whether I am recording or not. Yes, I am recording. So to factorial of a number. Fine. Smaller problem in order to minimize my self work will be to find factorial of a number n minus 1. If I choose this as my smaller problem, if my smaller problem is n minus 1 factorial, my self work, my SW self work will be n into smaller problem. I need to multiply just one item to my smaller problem. This will yield me correct result. I'm assuming that smaller problem will give me correct output. Now, bigger problem, smaller problem. Now comes what? Smallest problem. This is very important. Why I am emphasizing on smallest problem? You cannot keep on dividing bigger problem into smaller problem, then smaller problem into further smaller problem. There will be a time when problem is indivisible. So I need to find that state, I need to find that scenario, I need to find that situation where my problem cannot be further divided. So in this case, I told you that smallest problem will be 0 factorial or 1 factorial, right? Factorial 0 or 1 factorial. This will be my smallest problem. Self work is equal to n into SP, and in this case my SP is n minus 1 factorial, so n into n minus 1 factorial. I'm assuming that this smaller problem will give me correct result. Now let us see how we can write it in code, how we can write it in programming form, right? So I'm writing the pseudocode. Let's say my function name is, I will write this on Eclipse IDE as well. Let's say my function name is what? Let's say my function name is factorial, FACT. N is the parameter. I'm writing a pseudocode. Fine. So identify the smaller problem. Int SP. Let's say SP is my smaller problem. This will store factorial of n minus 1. Okay. Return the self work. What will be my self work? Int SW is equal to n into SP. Return it. Return SW. Fine. Will this code work perfectly? I think not. Why? Because I will divide n. Let's say n is 5. Let's say n is 5. 5 will call factorial of 4. 4 will call factorial of 3. 3 will call factorial of 2. 2 will call factorial of 1. 1 will call factorial of 0. 0 will call factorial of minus 1. This will call minus 2. This will call minus 3. Oh my god, this is keep on going. I need to stop it. I will stop it as soon as I reach to a situation where n is equal to 1 or n is equal to 0. Simply return 1 in this case. Fine, because 1 factorial is equal to 1 and 0 factorial is also equal to 1. Now, let us see how is it working. Fine, and we'll do the complexity analysis as well. So, and why this is not preferred, why this code is not preferred, I will discuss that too. So, I was finding, my aim was to find factorial of 5. Each time you will call the function itself, you can see that the bookish definition is correct. I am calling the function itself, right? But some changes are being happening. My parameter is being reduced to a value so that it cannot be reduced further. Fine. So I am calling factorial of 5. Factorial of 5 called a smaller problem or asked another person to find factorial of 4. So let's say this was my person A. This is my person B. Person B asked person C to call or give me factorial of 3. Person C asked person D to give me factorial of 2. Person D asked person 1 to give me factorial of 1. Will person E ask person F to give him factorial of 0? I don't think so. Why? Because I have reached to a point where there is no meaning in dividing n further. Fine. So person E will directly return 1 to whom? Person D. Now, person D has smaller problem as 1, so his self work will be 2 into SP, which is 2, and he will return this self work to F3. F3 smaller problem becomes 2, and self work will be equal to 3 into SP, which is 6. He will return 6 to F4. For F4, SP becomes 6. So self work is equal to 4 into 6, which is 24. He will return 24 to person A, which is SP for him. SP is 24, and SW will become 5 into 24, which is 120. He will return this answer, and we can print this on console, and we will get 120. Indeed, 5 factorial is equal to 120. Fine. What is happening in behind? Let us see that too. What happens when a recursive function is called? There's something called call stack. Okay. So whenever you know that uh, Java function execution starts from main function. Fine. This main function is stored in the stack, call stack, or activation record, what we say. Fine. Function call stack. So main function will call factorial of 5. This main function will call factorial of 5. Factorial of 5 will call factorial of 4. Factorial of 4 will call factorial of 3. Factorial of 3 will call 2. 2 then 1. 1 will return the answer. How many functions at a time in the call stack are present? I will say if I am finding factorial of n, then n plus 1 function frames will be created in call stack. Now I ask you a question. Is this a good thing? Is it really a good thing? Is this recursive problem better than iterative problem to find factorial of a number? I believe not. Why? Because for if I say if n is equal to 10 raised to power 5, total 10 raised to power 5 function frames will be created in your call stack, which is highly inefficient. We don't have this much memory. Fine. We don't have this much memory. We need to do it efficiently. We don't have unlimited memory that we can spend my whole call stack in storing function frames. Fine. So, and also understand it realistically. Person A can contact how many person? I mean, if you are finding 10 raised counting 10 raised to power 5 items, is it really good to contact 10 raised to power 5 people to count just 10 raised to power 5 items? I don't think so. So this is a major drawback of recursion, that we need to take care that minimum number of frames are stored in stack. And for that, we make use of something called dynamic programming. Okay, it is nothing. Okay, this name is complete hoax. This in dynamic programming, basically we use arrays or we use some storage data structure that stores overlapping problems. Fine. So let's so what is the complexity, right? What is the complexity? Let's see what is the complexity for factorial of for finding factorial of a number. Fn will contact fn minus 1, fn minus 1 will contact fn minus 2, and so on till we reach to a base level, which is f1. What is the height of this tree? Height of this tree will be n. Fine. And at each level, this is my level, this is my level 1, this is my level 2, this is my level 3. At each level, how much work is done? How much self work is done? What is the complexity of it? O1, right? Self work is doing nothing but multiplication. Multiplication can be done in constant time. Fine. So O1 in level 1, O1 in level 2, O1 in level 3, in all levels or in every height, I'm doing O1 of time. So my time complexity will become 1 into n, which is On. Fine. Time complexity On, space complexity is also On. This is the major drawback. Fine. So fine. I guess this much information is enough to understand recursion. Now we will discuss a problem named English ruler. It is a crazy problem. Okay. This will help in understanding how to identify bigger problem and smaller problem. So what is my task? My task is to create this pattern. Fine. Create this pattern or create this English scale with length 4, which means that 4 units can be calculated using this scale. And with maximum ticks should be 4. What do I mean by maximum ticks? Number of dashes. If you take a English scale, you will see that there are dashed lines in it, right? So maximum ticks should be 4. So 0, 1, 2, 3, 4. What this question is saying that you need to create such patterns with having 4 maximum ticks, and beside them there should be units, right? And in between these units you have to create this pattern. You have to create this pattern, fine, so on. So what is this pattern and how to create it? First of all, why to use recursion in it? Why can't I use iterative uh, algorithm in order to solve this problem? It will be really hectic. You can't make uh, it will be really, I mean, you cannot make this iteratively. If you try, it will be really messy when you do the coding. Fine. So the reason why we are going to use recursion is that I can see a pattern. I can see this pattern. Fine. And this is called repetitively. I can see this here, I can see this here, I can see this here, here. So it is better to use recursion to solve this particular problem. So maximum ticks are going to be 4, and in between these 2 units, I need to form this pattern. So let me change the color. This pattern. How can I form this? Observe the pattern carefully. For maximum 4 ticks, I can see that in the middle there are 3 ticks. Fine, there are 3 ticks. Fine. And between the maximum ticks, which is 4 ticks, and this 3 ticks length, there is this pattern. Fine. And if you see this input value for length 4 and maximum tick 3, for maximum tick 3, middle value has 2 ticks. Above it are 1 ticks and below it are 1 ticks. One more careful thing to observe. Above this 3 ticks here, I have this pattern. Let's say this pattern is P80 and I have same pattern below it, P80. Fine. Same goes for this as well. Above this 2 ticks, I have a pattern P80. Below this, I have a pattern P80. So there is something repetitive going on here, right? And what can I see else? P80, 3 ticks. Fine. Now let us make this pattern for maximum tick as 5. According to my observation, I believe that for maximum tick 5, there will be 5 ticks first. In the middle, there will be 4 ticks. Above this, there will be some pattern. Below this will also be the same pattern. And I can map this pattern to this particular pattern, which is the pattern for maximum tick 3. Fine. This is same, right? So I believe that this pattern will be pattern of maximum tick. Let me check. Maximum tick 3, or I must say 4, right? To maximum tick 3. 4, PAT of maximum tick 4. Fine. Now my task is to find pattern for maximum tick 4. Let's see. Pattern of M tick 4. Wait a second, guys. Wait a second. Here, let me write maximum tick as 2. So here, there should be maximum tick 3. Let me write it here, 3. I will tell you what I'm doing. Fine. Pattern of maximum tick 3. If I see here, maximum tick is 3, pattern of M tick. There are 4 ticks. So this will be the 3 tick, right? 3 ticks, in between there are 2 ticks. Pattern of 2. Oh, sorry guys, I am doing wrong mapping. I should write numbers here for better understanding. I am repeating all again for better understanding, I think. So let's see again. Fine. First, for m tick 2, there will be maximum number of 2 ticks. In between there will be pattern of 1 tick. Let's suppose this is pattern of 1 tick. Fine. For maximum tick 3, 3 ticks, and in between I have 2 ticks. Here I have pattern of 1. Fine. Pattern of 1. I am mapping this with this pattern of 1. Fine. Below I have pattern of 1. For maximum tick 4, I have in between here, I have in between 3 ticks, right? I have in between 3 ticks. I have in between 3 ticks, and this is the pattern of 2. I can map this with this one. This is the pattern of 2. Fine. And this is the pattern of 2 again for m tick 5. Now let us make it for m tick 5. In between I will have firstly I will make 5 ticks, then in between I will have 4 ticks. Here I will have pattern of 3. Here I will have pattern of 3. Pattern of 3 is nothing but this whole. Fine. So pattern of 3 is equal to this. This is pattern of 3, which will be stored here. Fine. So I can identify a smaller problem. This is my smaller problem. This is my smaller problem. And this is my bigger problem. I need to create a scale with maximum tick 5. Then what is my self work? Let me write it clearly. Let's suppose for m tick 5, maximum tick 5, my bigger problem is to create a ruler with maximum tick 5. With maximum tick 5. I need to create this ruler, particular ruler. Smaller problem. My smaller problem will be to create pattern, let me write it clearly, pattern of 3. And my smallest problem, I will come here after a while. Smallest problem. What is my self work first? Let's see. My self work is to print pattern 3, then manually print n, or I must say 5 minus 1 ticks, 4, which is 4 ticks, right? Here I am printing 4 ticks here. So I need to print 5 minus 1 ticks, right? Then print pattern of 3. This is my self work, guys, in order to form that pattern. Apart from this, I will manually create this one, fine, because here 0 is changing, so I will need a iterative loop in order to create this kind of pattern, but this will be done recursively. Now what is my smallest problem? Smallest problem is pattern of 1. Fine. Pattern of 1 means simply write this dash or print this dash. Simple. So smallest problem will be pattern of 1. Okay. Now I'm going to write pseudocode first, then I will write both those problems that we have discussed today, factorial and English ruler, on Eclipse IDE, and we'll try if we are doing something wrong during coding, how to debug it, right? We'll see those things as well. Fine. Pseudocode. It is very important to write pseudocode first rather than directly going on Eclipse IDE or any online platform. Fine. It is better to write pseudocode first. Think twice, write code once. Fine. So, okay. Let's start. Fine. So I need to create a ruler with length is equal to, suppose 4, m tick is equal to 4. Fine. Now for length 4, I need to create such kind of things. This can be done by using a simple for loop. For int I is equal to 0, I is less than equal to length, I plus plus print m tick times maximum tick times dashes. Fine. Then call the recursive function. Call the recursive function. Let's say, let me name my recursive function as pattern. Pattern mtick minus 1. Fine. Then uh, this will create the pattern here. Fine. Pat of mtick minus 1. Close this close this curly braces. Once this is done, loop will repeat again, and these many pattern will be formed. Fine. Now, recursive problem, how to write the code of it. That is the major task. Pattern, let's say ticks. So what is my smaller problem? My smaller problem is to print ticks minus 1, pattern of ticks minus 1, right? Number of ticks. So here, then once I have formed tick minus 1, I have printed this manually. Manually print if I am forming a pattern of 3. If I am forming a pattern, I need to print 3 times dashes. Fine. So what can I do here? I can write a for loop for int I is equal to 0, I less than what, ticks I plus plus CISO means system dot out dot println in Java. So print dashes, that is it. Then again call this same function. Smaller problem. This is my self work, guys. And what is the base case, or what is the smallest problem where I have to stop dividing when it becomes equal to 1? When it's 1, simply print, or let me write the short form, CISO dash and return. That is it, guys. This is the code. Fine. This will create the pattern. So let us go to our Eclipse IDE, and there we will write the code. Fine. So let us go here. Let me create Java class. Name, let me name it factorial. Finish. Yep. Oh, I haven't defined a package. Sorry, guys. Wait a second. Delete. New package. Let me say recursion. Finish. Here I'm going to create a class, Java class factorial. Okay. Execution starts from main function. Let me write it. Main function. So let me take input sc is equal to new, and I need to import this package as well. New scanner system.in, int n is equal to sc next int. Fine. Then let me create a public function, public int fact int n. Fine. And I will write system.out.println fact of n. And okay, I need to write a static. Then why is it showing an error? Return karega. Okay. Now if, and never write base case first write sp problem. Smaller problem, sp1 is equal to fact of n minus 1 int sw is equal to n star n sp. Then return self work if n is equal to 0 or n is equal to 1. Return. Simple. So let's see how is it working. I am typing 5 and I'm getting 120. Fine. Now let us see second problem. That was English ruler. Crazy problem. Class. English ruler. So first let's create a main function. In main function I'm going to first import scanner class. Scanner system.in Now let's take input length. Let's take maximum dashes is equal to what? Should I take input? Okay, let's take an input. Fine. Then se dot next end. Okay. M dash, and I will manually I is equal to 0 less than equal to length I plus plus. Manually print them. System dot out print. I will write dashes here. Should I write underscore or dash? Let's see how it will work with dashes. Space. Okay. Wait. For int j is equal to 0, j is less than m dash j plus plus. System dot print the dashes. Fine. Once it's done, print the unit value I. Fine. Print, should I write ln or let me write like this, print ln. Then I will call my recursive function pat of m dash minus 1, right? So public static void pat int m or int dash. Fine. So if, let me write the smaller problem is pat dash minus 1. Then for in, let me check my pseudocode. What did I do here? I printed ticks. Fine. So for int I is equal to 0, I less than dash I plus plus, simply print them in single line. Once you have printed it, leave a line for int I is equal to 0. No. Simply pattern dash minus 1. Find a point where the problem cannot be further divided. Dash is equal to 0. Oh, sorry, 1. Will not reach to 1. We'll end this division as soon as we reach to 1. So simply print single dash and then leave a line. Return. What can I do further? Is this correct, guys? I believe it is. So let us check. I hope it will work. Otherwise, we'll debug it. Don't need to worry. It is working, guys. It is working wonderfully. But I'm getting this extra bad. This is because I need to print it then manually. Control plus C, Control plus V, and then I will write system.out.print ln.length, right? Yeah, that is it. Let's see. 4,4. Yep, it is working wonderfully. This is the English ruler that we have created successfully by using recursion. So I hope you got enough idea how to use recursion. You can now go on LeetCode platform and try out recursion problem. I mean, it is a wonderful website. There you will learn a lot many things. Fine. So thank you all. Thank you for watching this video.